This is example number 9. This is page number 104 in CRT of class 10. Here the example number 9 is saying a sum of rupees 1000 is invested at the 8% simple interest per year. Calculate the interest at the end of each year. Do these interest form an AP? If so, find the interest at the rate at the end of the 30 years, making use of this fact. We know that the formula to calculate the simple interest is given by the simple interest is the PRT by 100. Formula is simple interest SI is equal to PRT by 100. So interest at the end of the first year, it is 1000 rupees. Rate of interest is 8% and 1 by 1000. Sorry, 100. So it will be 80 rupees. So the interest at the end of the first year is 80 rupees. Similarly, the interest of the second year, it will be PRT by 100, then 1000 into 8 into 2 by 100, that is 160 rupees. At the end of the third, the SI will be same PRT by 100. This is first term, you can say T1, T2 and you can say T3. Then this is 1000 into 8 into 3 by 100 and that is 240. So you can see here the first term is 80, then second term is 160 and third term is 240 and so on, and common difference is 80 rupees. First term is equal to 80 and the common difference is 80. So question is find the interest at the end of the 30 years making use of the fact. So either you can solve by this formula. Here we have to use this. You have to solve this question by using the arithmetic progression. So yes, this is a AP. This is an AP, and we are going to find out what will be the term after 30 years. So then that is a T30. T30 means A plus n minus 1D, that is AP plus 30 minus 1 into 80, that is AP plus 29 to 80, that is 80 into 30, that is 2400. So 2400 rupees will be answer of this question. Example number 10. Example number 10. In a flower bed, there are 23 rose plants in the first row, 21 in the second row, 19 in the 13th row, third row, and so on. There are 5 rose plants in the first row. How many rows are there in the flower bed? So here you can see 23 is there, first row, then second row 21, and then 19, and then last it is last row, the rows in the last row, that is the 5. So question is how many rows are there? So here we have to find out, as it is given here, we can see here A is equal to 23 and B is equal to 20 minus 21 minus 23, that is minus 2. You can check the other also, 21, that is the minus 2. So finally the common difference B is equal to minus 2. So here we have to find out which number n is here for t. So Tn is equal to 5 is equal to 23 plus n minus 1 into minus 2. That is, this implies 5 is equal to 23 minus 20n plus 2. 5, this is 5. This implies 5 is equal to 25 minus 2n. That means this implies 2n is equal to 25 minus 5. This implies 2n is equal to 20. So n is equal to 20 by 2. That is 10. So here this term is 10th term, and this is the required answer. The number of rows are 10. So now exercise 5.2 is there. We have to solve all the question of this exercise, sub question and question also, and we will go further. It is page number 107 and point is 5.4. Sum of first n terms of an AP. Sum of first n terms of an AP. See, let us consider the situation given. Situation again in given section 5.1, in which Sakila put rupees 100 into her daughter's money box when she was 1 year old, rupees 150 on the second birthday, rupees 200 on the third birthday, and will continue the same way. How much money will be collected in the money box by the time her daughter is 21 years old? Here the amount of money in rupees put in the money box on her first, second, third, fourth birthday were respectively 100, 150, 200, 250 till her 21st birthday. To find the total amount in the money box on her 21st birthday, we will have to write each of the 21 numbers in the list above and then add them up. Do not you think it would be a tedious and a time-consuming process? Can we make the process shorter? This would be possible if we can find a method of getting the sum. Let us see. We consider the problem given to Gauss, about whom you read in chapter 1. To solve when he was just 10 years old. He was asked to find the sum of the positive integers from 1 to 100. He immediately replied that the sum is 5050. Can you guess how did he do? He wrote S is equal to 1 plus 2 plus 3 plus dot 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 plus 100. Simply again you can write here 100. Consider the problem given the Gauss, about whom you read in the chapter 1. So 100 plus 99 plus 98 plus 1. So just you write here, it will be 2s is equal to 101 plus 101 plus dot 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 plus 101. So 2s is equal to, it is 100 times, so 100 into 101. So s is equal to 100 into 101 by 2. So the sum is 5050. We will now use the same technique to find the sum of the first n term of an AP. A plus D, A plus 2D, dot dot dot. The nth term of this AP is A plus n minus 1D. Let S denote the sum of the first term. First term of the AP, we have S is equal to A plus D plus A plus 2D plus A plus n minus 1. In bracket it is D. So reverting the terms in a reverse order, we have